The firm Franz Xaver Meiller is a tradition-rich company active in the commercial vehicle manufacturing sector. SLF Oberflächentechnik has delivered new equipment to coat all of the chassis and vehicle superstructures at the Munich plant of this major manufacturer. A wide range of parts, constantly changing color schemes, and the quality of the coatings are challenging considerations for all those involved. In order to handle the daily volume of parts, we created 3 independent treatment lines that nevertheless share some of the same characteristics, including some of the same machinery. From the prep station to the drying station, each line has 3 sequential processing stations. While the lines have different purposes, the processing steps require that they all have similar cabins. Let's start with the prep cabin of line 1 or line 2. At a length of 10 meters, a width of 6 meters and a height of 5 meters, personnel have more than enough freedom of movement to complete all of their work. In addition to the masking of components, the work includes much sanding and grinding work, and a central extraction system was created to handle the dust created by these activities. The connections supply the devices with pressurized and exhaust air so that 90% of the dust created can already be extracted directly. Grinding particles that escape into the ambient air are captured by the vertical stream of air that flows from the filter ceiling to the in-floor extraction system. Instead of being located underneath the gratings, as is commonly the case in other systems, the filter mats here are located in separate SLF cassette filters. This increases the service lifetimes quite significantly. The cabin's other important features include excellent and uniform lighting of at least 1000 lux. Now let's move to a downstream priming cabin. At 11 meters, this cabin has a similar length and the lighting system also achieves the same values. 1 or 2 coating technicians work here in a cabin with a controlled air temperature of 22 degrees Celsius. Dust-free air flows from the large area filtration ceiling and falls at a settling speed of 0.3 meters a second, removing the overspray from the cabin through the in-floor extraction system. Because Line 3 has been designed primarily to handle complete vehicles, we can see here that component groups are moved with the help of these electric carts. The SLF coating cabins at Meiller have a sectional control system. In order to reduce energy consumption, the air control system is divided into 5 zones. Depending on the position of the coating technician, 3 of these sections are activated. Precisely calibrated motion sensors transmit the technician's current position to the control system. The system regulates where fresh air inlets are opened in the filter ceiling and which of the corresponding floor flaps are opened to target and extract the overspray. Compared to conventional ventilation systems, which must turn over 84,000 cubic meters an hour, the sectional system shown here makes do with only 50,000 cubic meters an hour. The extraction system in these cabins uses a 2-stage filtration process based on impact collectors and downstream cassette filters. The air guidance system of the impact separators causes a very significant percentage of the particulates to collect on an easy-to-exchange aluminium foil. Only a small amount of remaining suspended material needs to be captured by the filter mats. In order to ensure the workpieces are easily accessible from all sides, the processing line is equipped with a lifting device that can lift the entire transport car to the appropriate height as required. The lighting units are positioned around the workpiece in such a way that a uniform illumination of at least 1000 lux is achieved during all of the processing steps. With a width of 4.8 meters, the downstream drying cabin is somewhat smaller because less surrounding space is required. At 12 meters in length, this section of Line 3 is also long enough to accommodate complete vehicles manufactured by the Meiller company. The twin rolling gates seen here are used to save energy. The fully insulated cabin is heated with natural gas and operates in air recirculation mode. 50,000 cubic meters of air are recirculated per hour, while 2,000 cubic meters of air are exchanged. The user-selectable temperature range reaches as high as 95 degrees Celsius. The large numbers of parts processed here is also reflected in the approach to color management. Because of the variety of models, colors must be changed several times per shift. Whenever a new color container is used, program-controlled cleaning of the hoses and spray guns takes place. The filter and machinery level was installed above the 6-meter-high cabins. Here, we find the fan units, which have a capacity of 50,000 cubic meters per hour and cabin. All control systems work automatically, so we seldom see personnel up here. The fine filters, which are responsible for the dust-free air supplied to the coating cabins, are located in these easy-to-service cabinets. Digital differential pressure sensors, which transmit their values to the installation's main control system, are used to monitor the level of filter saturation. One of the 8 natural gas burners is located in a flow channel that also contains the humidifier for the water-based coating cabin. 225 guide fans are located directly in front of the water nozzles, and the turbulent air creates a fine mist used to produce the desired level of humidity in the cabin air. The window for this value is extremely precise for water-based coatings. This station also includes a disinfecting unit that treats the water used here with the appropriate additives. We supply a complex installation such as this one, which must operate for several shifts every day with an interface for remote maintenance. Any problems that occur can be analyzed around the clock by our technicians, who can make appropriate adjustments until the arrival of a service technician. To ensure that all color variations are ready to use in the current production run, one line is operated with solvent-based coatings and a second with water-based coatings. With a computer-assisted color control system like this one, the main focus is on processing speed and material savings. However, with the same amount of air supplied to the coating technicians, the water-based and solvent-based spray mists behave differently, so that full protective face masks are worn in one line, while partial masks are worn in the other. I've worked as a painter at Meiller for the last 15 years. I've worked here in this department for the last 2 years. Working with the new equipment is much more pleasant than before. One of the advantages, without having to use an electric cart, I can route the workpieces into the coating cabin with a chain conveyor. The chain conveyors are part of the equipment for both Line 1 and Line 2. The coating transport carts have a front axle equipped with a steering drawbar to which an appropriate coupling is attached. The conveyor line has fixed stopping points that are matched to the length of the transport car being used, and these stopping points are useful in allocating space to workpieces in the cabin. Of course, the positions also correspond to a lifting device like the one seen previously in Line 3. The auxiliary equipment also includes a pneumatically powered lift that can be used to lift components, for example tailgates, during the coating process. Another noteworthy equipment feature is used to save energy. The dryer cabin is equipped with a center partition that divides the room when the number of workpieces is small. Air and heat requirements can be cut in half in such situations because the first and second halves are supplied by separate equipment. The constant turnover of vehicles near the coating installation at Meiller Fahrzeug- und Maschinenfabrik is enough to convince the visitor after only a single day of the enormous variety in the company's product lineup. We are proud to support Meiller's efforts to boost quality and lower costs with equipment produced by SLF Oberflächentechnik.